Imagine a world where the energy needs of humanity are met by an inexhaustible source. Imagine harnessing the very power of the sun, not just during the day but ceaselessly, 24 hours a day, 7 days a week. This isn't science fiction. This is the promise of space-based solar power. For decades, we've looked to the sky and dreamed of a future where energy flows as freely as the starlight that reaches us. Now that dream is closer than ever to becoming reality. Space-based solar power, once a concept confined to the pages of scientific journals, is moving steadily from the theoretical to the tangible. Across the globe, scientists and engineers are working tirelessly, driven by the immense potential of this revolutionary technology. The future of energy might very well lie not on Earth, but in the boundless expanse above us. Join me as we explore this exciting frontier and delve into the world of space-based solar power. Together, let's unlock the secrets of a brighter and more sustainable future. Space-based solar power, or SBSP, is a revolutionary concept that aims to capture solar energy in space and transmit it wirelessly to Earth. Imagine massive arrays of solar panels, strategically positioned in orbit, constantly bathed in the sun's powerful rays. Unlike their terrestrial counterparts, these space-based power plants wouldn't be hindered by the limitations of our planet's rotation or atmospheric interference. These orbiting powerhouses would operate continuously, collecting solar energy with unparalleled efficiency. The captured energy would then be converted into a form suitable for transmission back to Earth. This continuous, uninterrupted flow of energy holds the key to a future free from the constraints of fossil fuels and the limitations of Earth-bound renewable energy sources. The advantages of SBSP over traditional Earth-based solar power are numerous and compelling. Firstly, space-based solar panels would have constant, unobstructed access to sunlight. They wouldn't be subject to the day-night cycle, weather patterns, or atmospheric attenuation that limit the efficiency of ground-based systems. This means a constant, reliable stream of energy regardless of time of day or weather conditions on Earth. Secondly, the intensity of sunlight in space is significantly higher than what reaches the Earth's surface. This means that SBSP systems can capture significantly more energy per unit area, making them vastly more efficient than their Earth-based counterparts. And because they are in space, these solar power plants can be strategically positioned to beam energy to different parts of the globe, potentially providing power to remote areas or disaster-stricken regions. Section 4. Bridging the Celestial Gap Energy Transmission. One of the most fascinating aspects of space-based solar power is the wireless transmission of energy from space to Earth. This feat is achieved through the use of microwaves or lasers, which can transmit energy over long distances with minimal energy loss. The energy collected by the solar panels is converted into microwaves or lasers and beamed to receiving stations on Earth. These receiving stations, typically located in remote areas, would then convert the microwaves or lasers back into usable electricity, which can be fed into the existing power grid. While the technology for wireless energy transmission is still under development, significant progress has been made in recent years, bringing us closer to the reality of beaming clean energy from space. Section 5. The Pioneers of Space-Based Solar Power. The pursuit of space-based solar power is a global endeavor, with space agencies, research institutions, and private companies around the world actively involved in its development. The European Space Agency has been a strong advocate for space-based solar power, recognizing its potential to revolutionize the global energy landscape. They have conducted extensive research and feasibility studies, exploring various aspects of the technology. In the United States, NASA has a long history of research and development in space-based solar power, dating back to the 1970s. More recently, they have partnered with private companies and universities to advance key technologies required for space-based solar power, such as high-efficiency solar cells and wireless power transmission systems. China, Japan, and India are also making significant strides in space-based solar power research, recognizing its potential to address their growing energy demands. Section 6. The Promise and the Price of Orbital Energy. While the potential benefits of space-based solar power are undeniable, there are also significant challenges that need to be addressed. The most significant of these is the cost. Launching and assembling massive structures in space is an incredibly complex and expensive undertaking. Developing the technology for efficient wireless power transmission also comes with its own set of challenges, requiring significant investment in research and development. There are also environmental considerations. The potential impact of microwave or laser beams on the atmosphere and wildlife needs to be carefully studied and mitigated. Despite these challenges, the potential rewards of space-based solar power are too great to ignore. As technology advances and the cost of space access decreases, space-based solar power is becoming an increasingly viable solution to our future energy needs. Section 7. A brighter future, powered by the stars. The successful development and deployment of space-based solar power could have profound implications for humanity. It could provide a clean, inexhaustible source of energy, helping to mitigate climate change and reduce our reliance on fossil fuels. It could power our cities, industries, and transportation systems, ushering in a new era of sustainable growth and prosperity. Space-based solar power also has the potential to transform life beyond Earth. It could provide power for future lunar or Martian outposts, enabling us to establish a permanent human presence in space. The energy beamed from space could even be used to power spacecraft, enabling us to explore the cosmos further and faster than ever before. Space-based solar power is not merely a technological marvel. It is a symbol of human ingenuity, our unwavering determination to overcome challenges, and our boundless capacity for innovation. As we look to the future, let us embrace the possibilities that space-based solar power offers for a brighter, more sustainable future for all.